The growth of solar energy generation is an integral part of the energy transition. But finding sustainable solutions for photovoltaic panels that reach the end of their life cycle is also a growing challenge. The PHOTORAMA project is paving the way for the recycling of millions of tons of PV waste. This project is developing a circular model to reuse materials like glass, aluminium, copper, silver and silicon from old solar panels. The work of this Horizon 2020 project was recently recognized at the EU Sustainable Energy Week Innovation Awards. We were at the event in Brussels and Areti spoke to Claire Agraffeil, the EU project coordinator from the French Alternative Energies and Atomic Energy Commission, the CEA. The CEA plays a key role in the PHOTORAMA project, including coordination and the technological development for pre-industrial integration. Let's find out more.
Claire, your project won an award at the European Sustainable Energy Week 2024. That's a prestigious award, especially for projects. What do you think made your project stand out?
I hope the topic. You know, we do develop recycling technology of for PV panels. So this is about the green transition, and this is about to make the full circularity in the value chain. So I hope it's the topic, and I wanted to give a warm thank you to the European Commission, to our agency, and also to the public for voting for our project.
I would like to ask you to elaborate a little bit on PHOTORAMA project for us and give us its most important aspects.
So the PHOTORAMA project, the main focus of the project is to implement a circular model within the photovoltaic value chain. And the second aspect that we, I would say, on the technological development, we focus on the waste management and on the development of recycling technologies. This is research and development, so this is a lot of challenges. And you know, research and development, sometimes it works, sometimes it doesn't. And what I can say is that in our project, in our team, we really work hard and together, most importantly together. And we found out solutions, and we are going forward to a successful model. But I wouldn't say that it was an easy way.
Can you give me a couple of examples of, let's say, some major issues that you faced down the road?
I could go very deep, you know, in the technical side, but I think it's more easy to understand that our project was kind of very challenging because it's many steps. We've developed several technologies that are actually interrelated. It means that, you know, each step depends on the next one. And in that design, we had to make fit, the output fraction from one step to another. Maybe it's important to explain you very rapidly the principle. A PV device, a photovoltaic panels, is quite simple design. You have a multi-layer sandwich that is surrounded by an aluminium frame and electric junction box, electric components. So the idea of our project is to disassemble properly each component to recover the materials without mixing them, meaning that we can get a higher purity of each materials. This is not what's what happened in the field today, because at industrial scale, you have mostly shredding, crushing process that mix the materials, and you cannot recycle at the high value. We call that downcycling. Our purpose, our objective is to showcase a business model, a viable business model where we can recover high-value materials.
So I see that one of the materials that you recycle, correct me if I'm wrong, of course, is silver.
Yes.
How difficult or easy is that, and how much does it cost? And is it cost effective, let's say, because silver is a very expensive material?
Yes, it is, and this is one of our targets. You have to know that I was talking about the current practices.
Yeah.
Those current practices they don't recover silver, they don't recover silicon, and they So in our project, as mentioned, the idea is to separate components. So when we open, because this is a multi-layer sandwich, when we open the sandwich, we can get access to the solar cells. And after a delamination process, a separation process, we can get access to the solar cells. And when we have access to the solar cell, we can recover silver, but using environmentally friendly processes. Because today, again, at industrial scale, you have mostly hydrometallurgical, which kind of process, which is not all good for our planet. So we try to, we've developed a process that enables the recovery of silver using green solvents. And you were asking about the business case, because it's very important. And this was part of our challenge, and maybe it was one of the biggest challenge of our project. It was to make work the technologies, and to make them as a viable business case as a whole. And I cannot, because we are 3/4 of the project. I'm actually very excited. Today we have each unit that were brought in Germany, and we are setting up the pilot line with all of our 6-7 technologies. And now in 1 month or two, we'll run for 6 months a demonstration with over 100 tons of photovoltaic waste. And we will give more answers, but we've worked all along the way to make this business case viable. And so we are very confident that we can open up opportunities for high-value recycling to showcase and to demonstrate that it's possible.
And do you think that will be possible throughout Europe, so geographically speaking, in the north, in the south, west, east? Or there will be problems related, first of all, to policy and laws and regulations that are different in every European country, and second, to, I don't know, how open the governments, the companies, the people in the end are?
Of course, I think we can, and this is why we have to show that it works. In Europe, there is one directive, the WE directive, where the photovoltaic panels as a waste are included in. And, this directive is for all the member states. So even though it might be a bit different in different parts of Europe, the great progress, and as a precursor, Europe has made mandatory, the recycling of photovoltaic panels. But I don't see, there will be issue on the way, but I think it's possible. And the idea is, again, to duplicate this model through Europe and over the world, of course. And beside that, I would like to tell also that this circularity as a model, because one of the issues that we've seen, and when we've set up the design of the framework of the project, was you know that in a value chain, whatever the component, the product, whatever we talk about, you know, the manufacturing side and the recycling side, there are two different industries that they don't work together. And, you know, the idea was to bridge, to create dialogue. And I think, you know, beside duplicating our model, the idea also is to make an example for other fields with, you know, a broad view as I've said just before, that solar energy, you know, is kind of at the very front today of the climate fight. And I said that we should be exemplary. And our project was also to make a concept, the circular model, a reality, but at the very first, it's about making experience in the field, from concept to the field.
Exactly, creating, let's say, a role model, perhaps for others to follow. Yeah. But here's the thing: there is this new act, relatively new act, that the Commission has implemented, the Raw Material Act, which, in a way, also applies to you, right? Because you do deal with raw materials, even if they are recycled. How do you cope with that? Because there are some very specific mechanisms and some do's and don'ts that maybe apply to you or not.
Oh, it is. And I think this act will support our field more than anything. This is a very good start. We have, you know, some of the critical raw materials that belong to the list of the critical strategic raw materials. And that's for sure, this is a real support for us. But I also want to tell that, you know, even if it's not on the list, some of the materials are valuable. You know, like we have more than 70% in weight of glass. And it looks easy to recycle glass, but it's not. It's not. You already have contamination or a thing that, you know, avoid to go to the upcycling field, or, you know, this will be downcycled or not recycled or landfill or yeah, whatever. But it's also very important.
Yes, and it's also important to be environmentally friendly and within the right ethical, let's say, measures. However, would this impede a little bit our competitiveness? So you have to follow rules. Your project has to comply to environmental rules, to ethical rules that we have here in Europe. Your competitors in other continents, in other countries, perhaps do not. I mean, I know the answer, but I still have to ask you: is that a problem?
I would say that waste management and recycling is a different field, you know, because, okay, most of our product, most of the PV panels, they are coming from Asia.
Yeah.
But, the waste, they are on the ground. They are on the European ground.
Exactly.
So we will have, whatever happens, we will have to deal with it. So it means that, you know, this is not about competition. Recycling is a bit different. We also have a business, and it's happening all over the world. But what I would say is that now the priority is to make an efficient system, an efficient model in Europe. And for that, you can only focus on the economic side and the benefits, but in our project and in our concept, it was to make a whole, a model as a whole, yes, with only environmental friendly technology.
If you had a magic wand and you could change something that has to do with the project, of course, what would that be? Just only one.
Okay. So if I had one wish after this project, is that awareness of we can do high value recycling, what we call upcycling, that it can become more than a good practice, just the next practice in the next decade.
Perfect. Thank you so very much. Let's hope that this actually happens, because it is within the sphere of possibility, I think, right? Thank you so much.